Hello pre-calculus students, and welcome to a video on analyzing graphs. So for this video, for this lesson, we're going to focus on getting information just from the graph. We're not going to worry about the equation. In this case, it would be hard to even guess what the equation might be, and so that's not really relevant here. We're just going to focus on the visual from the graph. Okay, so first, learning how to read all of these kinds of questions, and this is just a duplicate of the same exact image. So there's a lot of different things that we can ask about a graph, as you can see here. All right, so first let's just find f of 0 and f of 2. So f of 0 is when the input is 0, and the input is 0, that's right here. That's when the x is 0, and the output looks like it's going to be -3. And then when the input is 2, that's going to be, when the input is 2, looks like it's right about here. And well, we're told on that one that the output will be -4. So when f of 0 equals -3 and f of 2 equals -4. Now I want you to pause the video and try B. Okay, so f of -5, a little bit hard to tell, but it's right there at 3 it looks like, and so f of -3 is a lot easier to tell. Right here, when the input is -3, the output is clearly 0, and here, and when the input is -5, it looks like the output is 3. It goes straight over there to 3. Okay, what about f of 1? So f of 1, when the x value is 1, the y value is somewhere around -3 or -4. We can't tell, but we can definitely tell that it is negative. So that's the answer to that one. And why don't you pause the video and think about D. Okay, so D is positive, right here. Okay, so for what values of x is f of x equal 0? Well, it equals 0 here, here, and here. So there's 3 different places, 3 different values, and it looks like -3. There's another one here. It looks like, well, it's given actually as 3.5, positive 3.5, and then the last one is at 5. These are the x values. Okay, for f, we're asked, for what x values is the value of the function less than 0? Okay, so when it's less than 0, we're talking about all the stuff, let's do this in blue, all the stuff not counting 0, not counting this, but everything below it. So all the values that we're looking at here. So basically, we're cutting off part of the function, and we're looking for the domain of this. It's just less than 0. So it'd be like from here to here, and then everything less, which goes from, it goes from -3 all the way to 3.5. Okay, but not including those endpoints. For all of those x values, the y's, or the outputs, are less than 0. So we're going to say from -3 up to 3.5. And because we're not including, right there, we're not including 0, we don't want to count those points, because then it would be equal to 0 at those points. All right, but the next one does say, if we count those points, for what values of x is f of x less than or equal to, and the only difference there is this time we would count these points, so that just changes the interval to a closed interval from -3 to 3.5. Okay, so if we want to know where f of x is greater than 0, we're going to look at, how about red again? So greater than 0 would be from here to here, and everything in between there, it's greater than, and also from here to here, and everything in between there. So there's 2 intervals where the outputs are above the x-axis or greater than 0. And we've got to make sure we include both of them. So this is going to be from -5 up to -3. And we're not going to include either one of those. Actually, -5, at x equals -5, it looks like we've got a point here that is -5, 3. So that's actually including -5. So we're going to have to include the -5 there. But we definitely don't want to include the 3.5, and we definitely don't want to include the 5. Okay. Now, for the domain of the function, we're looking at the same exact diagram here just to kind of get a fresh, clean diagram. The domain of the function just goes from -5 to 5. There's a point at -5. There's a point at x equals 5. Range of the function looks like the lowest point is down here at -4. The highest point is up here at 5.5, so that tells us the range. So from -4 to 5.5, inclusive. X-intercepts, we've already kind of answered that when we asked the question, for what values does f of x equal 0 up here? So it's going to be the same answers. It's these same points. The zeros are the x-intercepts. In fact, we use those almost interchangeably, especially if we say real zeros. The real zeros are the x-intercepts. So that would be -3, 3.5, and 5 again. Y-intercept, there's only one. It's down here at -3. Now we ask these questions about the lines y equals 1 and x equals -2. So you should know that y equals 1 is a horizontal line at 1. So it's something like, here, something like this line right here at 1. And if I can get it straight, there's that one. And it looks like it crosses the graph 3 times. And then we've got this vertical line at x equals -2, so that would be this one. And it looks like it's going to cross just 1 time. Okay, so for what values of x does f of x equal -4? So again, now we're looking for the y value. This is the y value being -4. So we're looking right down here again. And it looks like when x is 2, y is -4. Now look at that wording with the where and the what. For what values, that's the y, and where, that's the x. And that's just one of the ways that we kind of think about that, that function notation, where the where is like the independent variable of the inputs, and the what is like the outputs or the dependent variable. Okay, so anyway, that occurs at 2. Where or what x values would be x equals 2. You can write x equals 2, and that's okay. Oops, x equals 2 there. And last question here, for what values of f of x is x less than or equal to 0? So now we're looking for y's where x is less than 0, less than or equal to. So up here, we were looking where f of x is less than or equal, or f of x is greater than, but now we're looking at x. So this is going to be looking at where x is less than or equal to 0 would be from here. Let's just do this in, we don't have much blue on here, so let's choose that. So it would be looking at here all the way to here. All of these y values, all the way up to this one, which is actually at 5. For all of those y values, x is less than or equal to 0. So we've got to go from -3 all the way up to 5. Okay? We're looking when x is less than 0, so that's a left-right kind of a thing. Okay, let's do the second part here. So how can you tell whether a graph is a function or not? Hopefully you guys remember the vertical line test. And that just means if there's, as long as there's not more than one vertical line, as long as no vertical line crosses the function at more than one point, it's a function. So here, if you look, they show you 2 vertical lines in the diagram, there's no vertical line that will cross more than one. So this is a function. We'll pause it and let you guys do the other 3, and then I'll have the answers there. So pause your video. Okay, so the first 2 are functions. They pass the vertical line test because There's no vertical line that will cross more than one point. The second two are not functions because there's at least one, and there are many, vertical lines that do cross more than one point. And by the way, going back to the previous video, this would be the equation y squared, I think it's y squared equals x, which means there's a y squared term, and that rules it out from being a function. And this one would be something like x squared plus y squared equals 1. And remember, same thing, can't have that y squared term. Okay, when finding domain, include the x values of all points. So this is just more practice finding domain. We want to make sure that we look for holes, asymptotes, and any points beyond the graph. So if there's an endpoint, not an arrow, but an endpoint, then we want to stop that. Okay, so like here's an endpoint here. So we don't want to include anything to the left of that endpoint as part of the graph. Here in C, the function is trapped between the asymptotes. Here in B, there's an asymptote that's just a single point exclusion from the graph. And here in A, it looks like it's going to go on forever in both directions. So as far as the domain, we're looking for the domain and the range. So as far as the domain, we've got for A, the domain is all real numbers. Here for A, the domain is everything except for 0. So we're going to say it is negative infinity to 0 union with 0 to infinity. That's how we exclude a single point. From here, it looks like the domain is just negative pi over 2 to pi over 2. And not including those endpoints because there's asymptotes there. And here, the domain is starts at 1 and it ends, but does not include 5. So for this one, the domain is going to be 1 to 5, not including the 5 because there's an asymptote, and including the 1. Okay, I'm going to pause it and let you guys try to find all of the ranges. Okay, so there's the ranges. Most of these aren't too bad. The fourth part D, I just want to make sure that it's clear that the 2 is usually not too bad. That's an open point, so we're not going to count it. Sometimes when people look at this, they say, oh, it only goes up to 4. But it doesn't matter that it goes up to 4 on this side. What matters is that there are y values all the way up to infinity, which is indicated by this. So even though one part of it stops at 4, the other part has points like maybe, I don't know, maybe 4.95, right? And then there might be like a 4.99, 100. And all of the y values will be represented there, everything greater than 2. So this goes all the way up forever. Okay, for part B, let's just state the intercepts. So I'm going to pause the video and write in all the intercepts. You guys pause it too and see if you can get the same answers. Okay, there's the intercepts. I don't think any of these will be tricky. Okay, so then the last one is symmetries. So we're looking for any kind of symmetry, mainly with the x-axis, the y-axis, or rotational symmetry, which is the x and the y-axis. And this does go back to geometry. When you reflect over x and y, that's the same thing as rotating it 180 degrees. So if you see any of those, write them down too. So let's see if you can take a minute and write down the symmetries for each of these 4 graphs. Okay, and you can see that graph B is symmetric with respect to the line, the y-axis, and C is its origin symmetry, which really means rotation around the origin of 180 degrees. But we're just going to call that origin symmetry in this class. Okay, I hope you found this video helpful.